All right, everybody, we have a couple of examples on 30, 60, 90 triangles because you will be expected to find missing side lengths of a 30, 60, 90 triangle given one of the side lengths. So a couple of examples here. First one on the screen here, we have a 30, 60, 90 triangle. How do we know it's a 30, 60, 90 triangle? Because we have a 30-degree angle, we have a 60-degree angle, and then this has to be a 90-degree angle because all triangles add up to 180 degrees. We also have a side length here that's given, and we have to find the missing two side lengths. This side length right here is 7. Now, if we recall the relationships of the side lengths of a 30, 60, 90 triangle, the side opposite the 30-degree angle, which is the side length we have here, is x. So this 7 is x. And then the hypotenuse of the 30, 60, 90 triangle, which is this side here because it's opposite the right angle, is always twice the length of the short leg here, which is 7, which is x. So therefore, the hypotenuse has to be 14 because the hypotenuse is twice the length of the short leg. How do we know that 7 is the short leg? Because it's opposite the smallest angle of 30 degrees. Then we turn to the long leg, the leg opposite the 60-degree angle. The length of this leg is the length of the short leg times the square root of 3. So this length is going to be 7 times the square root of 3. Where does the 7 come from? It comes from the short leg. Where does the times the square root of 3 come from? That is the relationship between the long leg and the short leg. The long leg is the square root of 3 times longer than the short leg. So given just this one value of a 30, 60, 90 triangle, we can then find the other two missing values. Not too bad of an example. It's pretty simple when you're given the short leg because you just got to multiply by 2 and then by the square root of 3 and you're done. But there might be an instance in which you're given, in this case, the hypotenuse. Now the hypotenuse, in this case, is 8. The hypotenuse is always twice the length of the short leg. We did that before where we had the short leg, we found the hypotenuse. Now we have the hypotenuse. How do we know it's the hypotenuse? Because it's the longest side opposite the right angle. This length is twice the short leg. Why did I put the 4 here and not here? Not because it looks like the short leg, but because it's opposite the 30-degree angle. So this side length is 4, and therefore this 4 is x. And then we can find the long leg because the long leg is the square root of 3 times longer than the short leg. So the long leg is going to be 4 times the square root of 3. And now we have all 3 side lengths when we were just given one side length, in this case the hypotenuse. Now we get into the fun one. The fun one looks like this, where we have a 30, 60, 90 triangle, and we're given the length of the long leg because it's opposite the 60-degree angle. The length of the long leg is 12. And if we recall the relationship or the value of the long leg of a 30, 60, 90 triangle is x times the square root of 3. This is that x times the square root of 3 length. And we know that 12 is x times the square root of 3 because 12 is the longer leg. So our job now is to solve for x. If we have a value for x, then we know the value of the short leg, and then we can find the value of the hypotenuse. So we're going to solve this algebraically for x to find out how long the short leg is. So when I look at this, I see the square root. That's pretty nasty looking. I need to get rid of the square root. The best way to get rid of a square root is to do the opposite of a square root, which is square. So we're going to square both sides of the equation here. Square 12, and then square x times the square root of 3, because what you do to one side of the equation, you have to do to the other. So what happens here, this can be simplified to 144, because 12 squared is 144. This x squared right here comes from x is being squared, and then the square root of 3 squared is from the square root of 3 also being squared. We have a little bit more simplification we can do. I don't know what x squared is, so that's not going to be simplified at all. But the square root of 3 squared can be simplified to just 3. Kind of cancels itself out there. Then I move that 3 in front of the x for best practice purposes for writing algebraic expressions. So this 3 right here comes from the square root of 3 squared. The square root of 3 squared is 3. And now we can solve for x by dividing both sides by 3. We get 144 over 3. That's equal to x squared, because I divided both sides by 3. 144 divided by 3 is 48. And then I can get rid of the x squared by just squaring both sides. So x is the square root of 48. And I'm just going to leave it as the square root of 48 because I don't know what the square root of 48 is. It's an irrational number, so no clue. So I'm just going to leave that as the square root of 48. That's the length of x, otherwise known as the short leg. So the short leg is the square root of 48. Now that I have the short leg, I can find the value of the hypotenuse because the hypotenuse is twice the length of the short leg. So square root of 48 times 2, what's that? Well, just write it as 2 times the square root of 48. That's how long this is. So now what we can do with the 30, 60, 90 triangle is if we know one side length, we can find all the others because of the relationships of these sides. And it doesn't matter how big or small the triangle is. If it's a 30, 60, 90 triangle, these side lengths will all relate to each other in the same way. You have x, you have twice x, and then you have x times the square root of 3.